Welcome back. In this section, we're going to start to look at antiderivatives. So just to start ourselves off, we've got a little fact here. If you have the function 5x cubed, we know with power rule that the derivative is 15x squared. And up till now, we've written that relationship like this, that the derivative with respect to x of 5x cubed is 15x squared. But we could rephrase that. Instead of saying 5x cubed, take the derivative, you get 15x squared, we could say an antiderivative of 15x squared is 5x cubed. So an antiderivative, that's a function where if something is an antiderivative, then when you take the derivative, you get that function. So when I say, what's an antiderivative of 15x squared, I'm asking you, what function has the derivative 15x squared? So let's look at some examples here. The first one, I have a function 2x. And when I find the antiderivative, I'm asking myself, what's a function whose derivative is 2x? And so right away, I'm thinking about my function capital F of x being x squared. And I know that that's an antiderivative of 2x. And that's because if I were to take the derivative of capital F of x, the derivative of x squared is indeed 2x. And I can do the same thing with the next one. For secant squared, I know that tangent has the derivative of secant squared. So an antiderivative of secant squared should be tangent of x. And again, notice I can justify this on the side. I'm correct in this because g prime, capital G prime, is the derivative of tangent, which is secant squared, which is what we were given. And now I ask us down below, can we find another antiderivative for these functions for f and for g? Can I find something else who has a derivative of 2x? And for sure I can. For example, if I think about 2x, something that has a derivative of 2x, well, I might have x squared plus 1. That also has its derivative being 2x. So x squared plus 1 would also be an antiderivative of 2x. Same thing with the g of x, little g of x being secant squared. What's an antiderivative of that? I could go with tangent of x plus 2024. So that would also have a derivative that's secant squared. So that means that tangent of x plus 2024 is also an antiderivative for little g. So what this really brings up for us is the fact that for any function that we're interested in, there's not just one antiderivative. There'll actually be infinitely many. 5x cubed plus 1, or plus 1,000, or minus any number, all of those, they all have the same derivative. All of them are antiderivatives of 15x squared. So normally what we do when we're saying here's an antiderivative of a function is that we express that family of functions by using a constant. So instead of just saying a particular one like 5x cubed plus 1 or 5x cubed plus 1,000, I'm now going to refer to all of them by saying capital F of x is 5x cubed plus c, where c is my constant of integration. It's a real number, and for any real number, capital F of x would be an antiderivative. So if c is 1, for sure, its derivative is 15x squared. If c is a billion, its derivative is also 15x squared. For any constant c, this function, capital F of x, would be an antiderivative of little f of x. And then how we express this in symbols is this. We write the following: the indefinite integral of f of x. So here, this whole expression on the left-hand side, that's the indefinite integral. I would refer to the function that I'm integrating as the integrand. And dx, this is my variable of integration. This is telling me we're integrating with respect to x. X is the variable here. So the indefinite integral of f of x with respect to x is its antiderivative. capital F of x plus constant c. Okay, so let's do a couple of examples, finding some indefinite integrals. So when I write this indefinite integral of negative cosecant theta cotangent theta d theta, I'm asking us what is the antiderivative of negative cosecant theta cotangent theta, or what's an antiderivative of that? So I'm thinking back to trigonometry, and I know that the derivative, so I'll make a little note here, that I know the derivative with respect to theta of cosecant theta is indeed negative cosecant cotangent. So that means if I were finding the indefinite integral of negative cosecant cotangent, that should be cosecant theta. And of course, cosecant theta plus any constant c has that same derivative of negative cosecant cotangent. So my indefinite integral is cosecant theta plus constant c. All right, next one, 1 over 2 square root of u. That hopefully is a familiar one. I know that whenever I've taken the derivative of square root of anything, it's been 1 over 2 square root of whatever the thing is that we're taking square root of. So it looks like square root of u plus constant c should be my indefinite integral. And that's because, again, derivative of square root of u is 1 over 2 root u. So, of course, the whole idea of something being an antiderivative is that it's the opposite of the derivative. So if we had some indefinite integral and we thought we'd found ourselves an antiderivative, if I thought I'd found capital F of x, then if I were to take the derivative of my indefinite integral, if I took the derivative of my what I thought was my antiderivative, I'd get my function little f of x back. So that's a way that I can confirm that I'm right. If I think I found the correct antiderivative, then you can find that you're right by taking the derivative and seeing if you get the original function back. And so I'm going to use that right here for this example. So I'm confirming that this is true, that the indefinite integral of cosine cubed is this gigantic function that I've got going on over here. If that's the case, then I know that if I were to take the derivative of the right side of my equation, I should get cosine cubed. So if this is correct, if the antiderivative of cosine cubed is that big expression, then the derivative of that big expression should be cosine cubed. So let's find out what we get. Let's take our derivative of negative 1/12 sine cubed plus 3/4 sine plus quarter sine x cosine squared, and then plus constant c. So if I can show that the derivative of all of that is cosine cubed, then I know that whoever did the work here on this indefinite integral did it correctly. So away we go. Let's start with the sine cubed. So we've got power rule to deal with, so 3 sine squared, and then of course chain rule derivative of sine is cosine. For 3/4 sine x, derivative is 3/4 cosine, and then I've got myself a little product rule to deal with here with my 1/4 sine and cosine squared, so let's do that. First thing as it is, derivative of the second, derivative of cosine squared is 2 times cosine to the 1, and derivative of cosine is negative sine. And then plus the second thing as it is, so plus cosine squared, times derivative of the first. And derivative of quarter sine is quarter cosine. Okay, so far it does not look like cosine cubed, but of course that does not mean that we're wrong. It just means that maybe there's some more simplifying that needs to happen here. Cleaning this up a little bit, I've got that negative quarter sine squared cosine. I've got 3/4 cosine, and then I've got minus 1/2 sine squared cosine. And then 1/4 cosine cubed. So one thing I can do right away, I guess, is to rephrase this, simplify this. I've got some sine squared cosines that I can add together. So I've got negative 3/4 sine squared cosine. Three-quarters cosine. And 1/4 cosine cubed. So we're kind of part of the way there. If we're taking a look at what we're trying to get, hopefully we want this to be equal to cosine cubed, and I have some of a cosine cubed showing up here, 1/4 of it. So now if I'm thinking what to do next, I'm thinking about the fact that I'd like to have cosine cubed showing up, and I've got sine squared, which is kind of in the way. So I'm going to use a Pythagorean identity to get that into all terms of cosine. Hopefully some things will cancel and clean up after that. We'll find out. So stay tuned. I'm going to replace the sine squared with 1 minus cosine squared. And now we're pretty much finished, because you'll see once I expand this, I'll have negative 3/4 times 1 times cosine, so negative 3/4 cosine. I will have negative 3/4 times negative 1 cosine squared times a cosine. That'll be plus 3/4 cosine cubed. And I've got plus 3/4 cosine from before and a plus 1/4 cosine cubed. And then I'm pretty much now finished, because the minus 3/4 cosine and plus 3/4 cosine, they were going to cancel each other out. And I'm only left with 3/4 cosine cubed plus 1/4 cosine cubed, which is indeed cosine cubed. So there we go. We've shown it. We've shown that our indefinite integral is correct. Indefinite integral of cosine cubed is this big expression, and we showed it by showing that the derivative of that expression does simplify to give us cosine cubed.